We are in video 10 of research methodology and IPR. So we have already started the module 3 in last video, that is video 9. So in this 10th video we will be learning about different types of sample designs with characteristics of good sample design. So in the last video we had learnt about what exactly you mean by sample design, how do you need to create it, what are the steps to be followed, and what exactly has to be included in the sample design, right? So we can list out some characteristics of a good sample design, like first one being it must result in a truly representative sample, and it must be such which results in a small sampling error, and sample design must be viable in the context of funds available for the research study, and also sample design must be such so that systematic biasing can be controlled in a better way, and it should be such that the results of the sample study can be applied in general for the universe with a reasonable level of confidence. So that is what is expected from the sample design. So in this diagram you are able to see the target population as well as the sample. So here the target population is the entire crowd wherein you can so here you are able to see the entire target population and sample. For example, this 4 which is circled, 4 numbers only you are taking from that big population of which is around 20, right? So that is what you call as a population as well as a sample. There are different types of sample design based on two factors, that is the representation basis and the element selection technique, right? On the representation basis, the sample may be probability sampling or it may be non-probability sampling. Probability sampling is based on the concept of random selection, whereas non-probability sampling is non-random sampling. On element selection basis, the sample may be either unrestricted or restricted. When each sample element is drawn individually from the population at large, the sample so drawn is known as unrestricted sample, whereas all other forms of sampling are covered under the term restricted sampling. The following chart exhibits the sample designs as explained above. Sample designs are basically of two types, that is non-probability sampling and probability sampling, right? So under this you have simple random and complex random and stratified, systematic, cluster sampling. Whereas non-probability sampling, convenience sampling, judgmental sampling, quota sampling, right? A census is a count of all the elements in a population wherein which constitute the entire population. So complete enumeration of all items in the population is known as a census inquiry. A population is a large well-defined collection of individuals known to have similar characteristics that will focus on scientific inquiry. The entire group of people to which the researcher wishes to conduct research and generalize the findings as he wants. So a census is a count of all the elements in a population. If 4,000 files define the population, a census would obtain information from every one of them. It can be presumed that in such an inquiry, when all the items are covered, no element of chance is left and highest accuracy is obtained. The process of selecting a number of individuals for a study in such a way that individuals represent the larger group from which they were selected. The process of selecting sample for the purpose of research study is called as sampling. The respondent selected should be as representative of the total population as possible in order to produce a miniature cross-section. The selected respondents constitute what is technically called a sample, and the selection process is called a sampling technique. The survey so conducted is known as sample survey. Algebraically, let the population size be n, and if a part of size n, which is less than capital N, of this population is selected, according to some rule for studying some characteristic of the population, the group consisting of these small n units is known as sample. Capital N is population, small n is sample. So coming to types of sampling or techniques of sampling. The first being the probability sampling. So probability sampling is also known as random sampling or chance sampling. Under this sampling design, every item of the universe has an equal chance of getting included in the sample. It is, so to say, a lottery method in which individual units are picked up from the whole group, not deliberately but by some mechanical process. Here it is blind chance alone that determines whether one item or the other is selected. The results obtained from probability or random sampling can be assured in terms of probability. That is, we can measure the errors of estimation or the significance of results obtained from a random sample. And also, this fact brings out the superiority of random sampling design over the deliberate sampling design. So, random sampling ensures the law of statistical regularity, which states that if on an average the sample chosen is a random one, the sample will have the same composition and characteristics as the universe. This is a reason why random sampling is considered as the best technique of selecting a representative sample. Random sampling from a finite population refers to that method of sample selection which gives each possible sample combination an equal probability of being picked up and each item in the entire population to have an equal chance of being included in the sample. This applies to sampling without a replacement. That is, once an item is selected for the sample, this applies to cannot appear in the sample again. For example, sampling with replacement is used less frequently, in which procedure the element selected for the sample is returned to the population before the next element is selected. In such a situation, what happens? The same element could appear twice in the same sample before the second element is chosen. In brief, the implications of random sampling or simple random sampling are: it gives each element in the population an equal probability of getting into the sample and all choices are independent of one another. Also, it gives each possible sample combination an equal probability of being chosen. Keeping this in view, we can define a simple random sample or simply a random sample from a finite population as a sample which is chosen in such a way that each of the combination possible sample has the same probability of being selected. To make it more clear, we take a certain finite population consisting of 6 elements like A, B, C, D, E, F, that is capital N being 6. Suppose that we want to take a sample of size small n is 3 from it. Then there are 6 C3, that is 20 possible distinct samples of the required size, and they consist of the elements like you can go with all permutation and combination ABC, ABD, ABE, like that. So if we choose one of these samples in such a way that each has a probability of 1/20th of being chosen, we can then call it as a random sample. So how do we select a random sample? In simple cases like as we discussed now, we can each write each possible samples on a paper and then mix these slabs through a container and then draw as a lottery or either through blindfold, right? So such a procedure is quite impractical if it is altogether having problems, right? So we can take a random sample in a relatively easier way, like without taking the trouble of enlisting all possible samples on paper slips. Instead of this, we can write the name of each element of a finite population on a slip of paper, put the slips of paper so prepared into a box or a bag, mix them thoroughly and then draw the required number of slips for the sample, one after the other without replacement. In doing so, we must make sure that in successive drawings, each of the remaining elements of the population has the same chance of being selected. This procedure will also result in the same probability of each. So this is how we select the sample as a random sampling, right? So the next being Proper definition of probability sampling. So it is also known as random sampling. The results obtained from probability or random sampling can be assured in terms of probability. That is, we can measure the errors or of estimation or the significance of results obtained from a random sample, and this fact brings out the superiority of random sampling design over the deliberate sampling design. In brief, the implications of random sampling or simple random sampling are: it gives each element in the population an equal probability of getting into the sample, and all choices are independent of one another. It gives each possible sample combination an equal probability of being chosen together, right? Next is the simple random sampling. Each element in the population has a known and equal probability of selection. This implies that every element is selected independently of every other element. The sample is drawn by a random procedure from a sampling frame. This method is equivalent to a lottery system. Take a population containing 4 departmental stores, A, B, C and D. Suppose we need to pick a sample of 2 stores from the population. We write down all possible combinations like AB, AC, AD, BC, BD and CD on piece of paper and fold the pieces. Mix them and all put one at random. First being the systematic sampling. In some instances, the most practical way of sampling is to select every ith or kth item on a list. Sampling of this type is known as systematic sampling. Sample is chosen by selecting a random starting point and then picking every kth element in succession from the sampling frame. So here there are 3 steps. Sampling interval k is determined by the following formula. K is equal to number of units in the population by number of units desired in the sample. Okay. So 1 unit between the first and kth unit in the population list is randomly chosen. Add kth unit to the randomly chosen number. For example, consider 1000 households from which we want to select 50 units. So k is equal to 1000 divided by 50 is equal to 20. To select the first unit, we randomly pick one number between 1 to 20, say 17. So sample begins with 17, 37, 57. Only the first item is randomly selected and rest are systematically selected. So that is systematic sampling. So the next being the stratified random sampling. So what do you mean by stratified random? So in this stratified sampling, what happens is, if a population from which a sample is to be drawn does not constitute a homogeneous group, stratified sampling technique is generally applied in order to obtain a representative sample. Under stratified sampling, the population is divided into several subpopulations that are individually more homogeneous than the total population that belongs to the different subpopulations are also called as strata. And then we select items from each stratum to constitute a sample. Since each stratum is more homogeneous than the total population, we are able to get more precise estimates for each stratum by estimating more accurately each of the component parts, and we get a better estimate of the whole. In brief, stratified sampling results in more reliable and detailed information. The following questions also they are relevant to the context of stratified sampling, like how to form a strata, how should items be selected from each stratum, how many items be selected from each stratum, or how to allocate the sample size of each stratum. See, for example, strata can be formed on the basis of common characteristics of the items to be put in each stratum. This means that various strata be formed in so here what happens that various strata to be formed in such a way so as to ensure elements being most homogeneous within each stratum and most heterogeneous between the different strata. The strata are purposefully formed and are usually based on past experiences and personal judgment of the researcher. So one should always remember that careful consideration of the relationship between the characteristics of the population and the characteristics to be estimated are normally used to define the strata. At times, pilot study may be conducted for determining a more appropriate and efficient stratification plan. We can do so by taking small samples of equal size from each of the proposed strata and then examining the variances within and among the possible stratifications. We can decide an appropriate stratification plan for our inquiry. So, in order to find out the answer for the second question which we asked, it is a usual method for selection of items for the sample from each stratum resorted to is that of simple random sampling. Systematic sampling can be used if it is considered more appropriate in the situation. So again, what happens is we usually follow the method of proportional allocation, under which the sizes of the samples from the different strata are kept proportional to the sizes of the strata. Like if you put P and N formulas, then probably you will get to know. So as in the slide, we will just move on with the stratified sampling method. If a population from which a sample is to be drawn does not consider a homogeneous group, then you create the strata. Yeah, we already learned that, right? So first one is we have proportionate stratified sampling. The number of sampling units drawn from each strata is in proportion to the population size of the stratum. To illustrate the same thing, let us suppose that we want a sample size of n is equal to 30 to be drawn from a population of capital N 8000, which is divided into 3 strata. N1 is 4000, N2 is 2500 and N3 is 1600. Adopting proportional allocation, we shall get the sample size as under for the different strata. With strata N1 is when it is 4000, we have P1 4000 by 8000. So here in N into P1. Similarly for strata N2, for N3, so thus using proportional allocation, the sample sizes for different strata are 15, 9 and 6 respectively, which is in proportion to the size of the strata, that is 4000, 2400, 1600. Proportional allocation is considered most efficient and optimal design. So next one being the disproportionate stratified sampling. So here the number of sampling units drawn from each stratum is based on analytical variation and consideration, but not in proportion to the size of the population of that stratum. When differences in the stratum size and difference in stratum variability, disproportionate stratified sampling technique can be used. So see, as and when we go deep into the different types of sampling technique and the stratas which are being used, so what we have to do is we need to check out the differences between the previous sampling techniques, whatever we have learnt of, and to find out the relation or the parameters which are there for each and every sampling methodology, right? So we are yet to start with this cluster sampling, wherein we will be learning about probability and non-probability sampling. So under probability we have these many points. So simple, random, systematic, stratified we have already learnt. So the one more thing is cluster sampling. So what exactly you mean by cluster sampling? That also I'll be able to tell you. So here we are in video 10 of RM and IPR, wherein we have covered with the different types of probability sampling except the cluster sampling, right? So we will be learning about the differences between stratified sampling, proportionate and disproportionate. So we'll learn the difference and then probably we can go with the differences between stratified and cluster sampling, and then go for non-probability techniques. Right. So I think we are done with video 10. So in video 11 we will finish off this third module of research methodology and IPR. Thank you.